Okay, we're going to go into Chapter 6 a little bit farther with 6.3, the solid state, 6.4, the liquid state, and 6.5, the gaseous state. These are not very long, so this video will not be very long. On this first page, you can see a solid is arranged and it doesn't fill the container that it's in. A liquid will conform to the container and it's sort of jumbled, but it doesn't fill all the empty space. A gas does fill all the empty space, and we're going to talk about each of these individually. Here we go. Okay, let's talk about the solid state first. First of all, in a solid state, cohesive forces are stronger than disruptive forces. Those are the things that hold things together. Second, each particle occupies a fixed position in a crystal lattice. They have a specific place. Third, kinetic energy causes the particles to vibrate in their fixed position. Solids also have high density. That means they're closely packed, large quantities of particles in a very small area. They have a definite shape. There's also a very small amount that can be compressed because it's very little space between particles. So most times we say it isn't able to be compressed. And the last thing that you need to remember about solids is there's very small thermal expansion. That means when I heat it up, they vibrate more, but they still stay in the same place. So they can't expand very far and still remain a solid. With the liquid state, we're actually now looking at particles that are randomly packed and relatively close to one another. So there's not a specific spot for each particle now. They're just sort of randomly in there and can move around. Liquids also are particles that have constant random motion. They slide freely over one another, but they don't have enough kinetic energy to separate from each other. They have high density. They have indefinite shape. They'll take the shape of whatever container they're in. They have a small ability to be compressed. That's because liquid, basically, they touch each other. The particles touch each other just like a solid. So they don't compress very easily, and we're glad of that because of our brake fluid and our brake lines. Otherwise, the brakes wouldn't work. Liquids also have a small thermal expansion for the same reasons that solids do. However, liquids do expand just a little bit more than solids would. Okay, so 6.5 gaseous states. The disruptive forces completely overcome cohesive forces between the particles, so the particles can move farther apart. Gaseous particles also they especially move independently of one another in a totally random way. Think like a toddler. They get distracted really easily, but they move beeline for what they want. They also have very low density. That's because the particles are spread out far apart. They also have an indefinite shape. That means they will take the shape of whatever container they're put in. They also have a large compressibility. That's because the particles are far apart so that I can compress them closer together. There's also a moderate thermal expansion, meaning that if I put a gas like in a balloon and I put it out on a hot day, that it's going to expand and make the balloon bigger. If I put it into a freezer, the balloon will actually get smaller. So I do have a moderate thermal expansion that takes place as I add heat to the container, if the container is elastic and can expand. So this is it with solids, liquids, and gases. See you in class.